Large tyres are the lifeblood of our mining, quarrying and construction industry. They have to absorb all the severe pressures and strains which are just part of this tough world called OTR, off-the-road tyres. They have to carry very heavy loads, sometimes great distances, between the rock face and the crusher plants. They can run at extreme temperatures and are subjected to fierce impacts with rocks and other debris. Sometimes, these impacts can be so severe that the tyre structure is seriously damaged. In this case, only a professional repair, completed by a qualified repair technician, can render the tyre suitable for further extensive service life. The cost of these giant tyres makes it extremely uneconomical to simply discard them. Repairing them can save the machine operator tens of thousands of dollars every year. From Australia to Europe to the United States of America, the one repair system that is internationally renowned is the REMA Tip-Top OTR tyre repair system. By using high-quality materials, specially designed tools and proven repair techniques, the OTR system can cost-effectively extend the life of seriously damaged tyres. The OTR system is centered around three very robust and extremely well-proven earth mover thermopress vulcanizers, known as EMTPs for short. The EMTP-1 is the smallest of these machines. It can comfortably handle tyres from truck size 1200/24 up to 3325/35 earth mover. The largest of these machines is the EMTP-3, which can handle the largest tyres used in the mining industry today. It's designated for tyre sizes 370057 right through to 5580/57. However, its design envelope is still open, and it will be capable of vulcanizing tyre sizes which are as yet still on the drawing board. This video will focus on the very versatile EMTP-2 machine, which is designed mainly for tyre sizes 240049 up to 360051. This machine can be extended by means of a simple giant attachment, which enables repairs up to tyre size 400057. In fact, each EMTP vulcanizer is capable of repairing some other tyre sizes which appear outside their design envelope. It's imperative to contact your nearest tip-top agent for specific technical advice before trying to choose the most suitable EMTP machine for your workshop. Really successful systems are based on very clear and sound technical principles, together with a well-proven concept. Whichever EMTP machine is chosen, the concept and inherent principles remain the same. Damaged, frayed or rusted material is removed from the injury area. This is replaced with high-quality repair materials vulcanized into the tyre using a tip-top EMTP machine. The EM thermopress applies heat and pressure to a localized area of the tyre. This localizing of the pressure and temperature avoids large-scale reversion and distortion to the tyre structure. The injury area is then reinforced using a high-quality, pre-stressed, pre-cured patch repair unit, which is produced in Germany to ISO 9001 international quality standards. In such a short information film, it would be impossible to display every type of repair. However, let's follow the progress of one tyre which requires repair. This will give an insight into what can be achieved with quality materials. On receiving the tyre from the mine site, the repair technician will first ensure that the tyre is clean and dry. A full tyre inspection is then carried out. The technician then marks each injury and records the information. The liner of the tyre should be inspected thoroughly for defects, Surface rubber is removed from the injury area with the use of a rotary gouge. The damage in the injury area is limited with the use of a compass saw. This is normally carried out from the outside of the tyre. A flex saw can also be used to limit steel cord damage. Further rubber can be removed using a donut or dome rasp. This provides a good shape and texture, which will be required when vulcanizing the new rubber compound into the injury area. When buffing directly on or above the steel plies, an encapsulated wire brush is used in order to avoid further damage to the steel cord. Any remaining sharp steel is then stoned using a high-speed rotary tool. The injury is now measured in the axial direction, then in the radial direction. These measurements will be used to select the correct tip-top patch repair unit from the chart. The measurements are recorded on the tyre sidewall. A depth of injury measurement is also taken. This too is recorded on the tyre. It will be needed later. To select the patch repair unit, the radial tyre section width is required. If the exact size of injury is not listed, use the nearest but larger charted injury size available. On bias or cross-ply tyres, the ply rating of the tyre is required, and only one injury size is used. The injury is always measured at the greatest extent of the damage. The outside rubber skive is now rebuffed if any improvement in the disc shaping is required. The injury inside the tyre also needs preparing by buffing. Checks should be made for liner separation or cracks that may extend under the liner. If any doubt remains about the integrity of the liner, it should be removed completely from the patch placement area. A brass cleaning brush is used to clean the outside of the tyre. The injury area on the inside is cleaned in the same way. This buffed area is now coated with tip-top MTR solution. The outside repair area is coated in the same way. Drying times are related to temperature and humidity, so this first coat of MTR solution should be left to completely dry. After the initial drying time has elapsed, a second coat of MTR solution is applied to the outside of the tyre. The inside also receives a second coat. Both are left to dry for a minimum of 15 minutes. MTR rubber is then extruded inside the tyre to create a working base that can be used later when completing the filling. The filling on the outside is completed also with the aid of a hand extruder. It's normal to overfill by 10 to 15 millimeters at the injury center. To help restrict the flow of rubber during curing, strips of cured rubber can be stapled around the injury. If completing a tread injury, it's also important to block any tread voids. Heating foil is often placed over the fill inside the tyre. This ensures that the curing rubber will not vulcanize itself to any part of the inner heating plate. Also, add center chalk marks on the outside to make positioning the machine easier. Before placing the machine into position, a best fit contour shape is selected for the inside of the tyre. A best fit contour shape is also selected for the outside of the tyre. Once selected, these contour segments are transferred to the EMTP machine. The repair area of the tyre is placed approximately in the 4 o'clock position. It may be necessary to spread the tyre beads in order to maneuver the machine into position. Using the center chalk marks as a guide, the machine's heating heads are closed manually first. Then pressurized to 100 bar using the machine's hydraulic system. Unlock the mainframe directional and lateral axis locks. The machine is now pressurized to 160 bar. This allows the machine to adjust itself to the tyre. The axis locks are then retightened. The cure time is calculated by taking the depth of injury measurement in millimeters and multiplying it by 5 minutes. The digital timer is set. The start button is then operated. The full cure can be monitored from 2 digital temperature control display units. The machine also incorporates a fail-safe device should the timer or temperature control exceed their parameters. However, as with any vulcanizing machine, it's essential to monitor the cure at regular intervals. At the end of the vulcanizing process, the machine is removed from the tyre. The fill area is immediately checked for strength and elasticity by applying pressure through a small hand tool. Also, a sample may be cut from the overfill to check that there is no porosity. To complete the second part of this repair process, it's important to relax the tyre beads. Then draw auxiliary lines inside the tyre which pass through the center of the cured fill area. The patch repair unit is then centered over the injury. Further auxiliary lines are drawn approximately 10 millimeters larger than the actual patch unit. Liquid buffer or liner cleaner is sprayed within the marked patch area. This is immediately scraped to remove all traces of silicone, graphite and other mold lubricants. The inner liner is now buffed using a 36 grit dome rasp. For companies who prefer to always remove the inner liner, Rima Tip-Top have developed a tool called Hot Cutter. This tool not only helps to remove the majority of the butyl liner material, but can also be used to remove old patch units which are obsolete. Final cleaning of the texturized area is completed with a brass cleaning brush. A vacuum is used to remove any debris. The first coat of Tip-Top OTR cement is applied to the buffed area and left to dry fully. This takes approximately 1 hour. Approximately 10 minutes before the end of the drying time, the protective foil is removed from the patch unit. The patch bonding layer is then coated with 1 coat of Tip-Top OTR cement.